Hi, welcome to this video on programming chess in Smalltalk. My name is Sander, I am the experienced programmer. After having seen both good and not so good YouTube videos on programming chess in a variety of languages, I thought it was time for a video on how you can do this in the 50-year-old language Smalltalk, which I think is still modern. What I will show you is a version 1.0 program, but fully functional. It has a board, it only allows legal moves, and pawn promotion, en passant, and castling moves are included. Players can be human or computer, so games can be between two humans, a human against a machine, or a fully automated game. So let's go over to Smalltalk and start with an overview of the classes. If you don't know Smalltalk, all classes are grouped into categories, which you can see here. These are not namespaces, by the way, which is an inconvenience because it requires that class names have to be unique. I will briefly discuss the classes that I have created. I think that developers in any object-oriented language will end up with mostly similar classes. So I guess we have the usual suspects like chess game, which has a board, has of course squares, and a square is on a board on a certain position with a name and a color, and it might have a piece on it. Pieces. Chess piece is the abstract base class for the concrete pieces that you see just below it, and these pieces have a color, are on a square, and some administrative attributes. And each of these pieces knows, well, how what kind of moves it can make. Talking about moves, this is a pretty simple class, just a from and a to attribute. That's all. No real intelligence here. Then we have the player, which is the base class for a computer player or a human player. And then the viewer shows everything to the user. And finally we have two classes that you may be unfamiliar with, namely the chess game state and the chess piece state. I will come back to these later on. Now I will show you some of the more interesting methods. Like in this class, you can see we have a lot of methods. And also here, this is the biggest class. But I will show you some of the more interesting. By the way, you can download the full source from GitHub. I have put a link to the repository in the description below. As you see, the methods of a class are also grouped in categories. These are just two categories, but for example, for the chessboard square we have several categories. The category private, this one over here, that's just a name. Nothing prevents you from calling methods in the private category, but it gives you an indication that the methods in the category should not be used outside of its class. If you are unfamiliar with Smalltalk, public and private do not exist as keywords in Smalltalk, but all instance variables are private and all methods are public. So let's start with the most important methods, the game loop. this is the looping construct. Inside these hooks here you can see the body, and this is the condition. As long as you are not over the maximum number of moves, as long as a move is still permitted, possible, please do this move. So what it does, it computes the permitted moves for the current player. If no more moves are possible, then we either have mate or stalemate, and if there are still moves possible, then the player should pick one of his or her choice and play that move. Now, of course, one of the first things you have to solve if you want to program a chess engine is this one, the permitted moves, because chess has its peculiar rules, so it's not quite, for some pieces it's not very easy to do. But this piece of code is well, pretty readable. This one and this one I will come back to later, but this is pretty easy. We start with an empty collection, we ask all the pieces with the proper color, please add your permitted moves, and if a move would result in a check afterwards, reject it. So I think that is pretty readable code, if I say so myself. Now, the hardest piece to determine the permitted moves is the pawn. Because the pawn can move one ahead, and then the first move it can maybe even move two ahead. But if it captures, it can only capture things that are diagonally ahead of it, not straight ahead of it. And this is the most difficult one, the en passant move. I have seen on YouTube a lot of programmers just say, well, I leave this as an exercise to the reader, but come on, this is the challenge. So how is this done? I go to the en passant move. You must look to your left and to your right, at least as long as you are not on the outer left or outer right. So, and then you have to check, well, this is an expression that looks if an en passant move is possible for the left side of you. So you go here, and you have to consider two squares diagonally ahead. That should be empty, as you can see here. And there's the adjacent square, and there are a number of conditions for that. It should be occupied by an opponent pawn, and the en passant condition should be true because you can only be captured en passant immediately after you have done two squares on your first move. If you pass over this opportunity, then en passant becomes false, and yeah, that is your chance. So you can see this is, well, it is readable, but it is not very easy. I contrast this to, for example, queen permitted moves. This is all permitted moves in directions. And what are the queen directions? It's a class method. The queen directions are straight ahead, diagonally ahead, to your right, etc. So 8 directions in total. If you look at the rook only has 4 directions, ahead or backwards and to the sides. And if you look at the bishop, 4 directions, but also always in a diagonal way. So those are much simpler. Okay, so we came from the game loop, and then we computed the moves, and we saw that for some pieces it was quite difficult, at least not very easy. So these permitted moves are passed on to the player, and the player must choose which move to play. Well, I only have one concrete automated player, and if you ask that player to choose its move, then this is all. Permitted moves is a collection at random, is a standard method from Smalltalk, and just chooses any of these moves. Very fast, not very brilliant. So let me get back to the game loop. This was the game loop, and as soon as the player has the player gets its moves from here, next move from, via the viewer, the player is asked, please provide your next move. So if the next move is not provided, it means the player gives up or there is no move possible. But if the player does choose a move, then it is executed. So that move is executed. This method is the one that I least like in my code, because we are working in object-oriented language, and every time you see these checks on classes, pawn and king, then you know, well, this is kind of fishy. But I don't know how to solve this the way I have currently done it, so if you have a suggestion, please let me know in the comments below. So let's see, do we execute other move? And that executes the simple move. And that finally puts the piece on the board. I'm going back to the chess game permitted moves because I promised I would explain this. The other code was easy to understand, but what on earth is this? The thing is, for every move that is legally possible, you do not want to end up in check after you have done the move, so you must check that this is not happening. And that is not easy thing, because you would like to make a move on the board and see what happens, see if any pieces are attacking you, but at the same time you cannot really execute the move on the board because it will mess things up. A piece knows if it has been moved or not, or if it is in en passant or not, so you would really like not to disturb those attributes. So what I am doing here is I am putting the board in a special mode, and if I go to the chessboard, there are 3 moving pieces related methods, and this was the method that puts the piece actually on the board. And here you can see something special for the probing mode. If the board is in probing mode, then the state from the piece is put onto a stack. And well, every time you see a push onto the stack, you know that a pop must come. So at the end, if you have done your probing, if you have checked that there are no moves, or if you have checked if a move would result in check, then you can do unmoves, and undo moves. It pops off one by one the pieces, the piece attributes, and restores the board as it was before you went to probing mode. So once again, permitted moves. This is the interesting one. Check would result after. Here you can see the undo moves after the executes. Also, the game itself has some properties that need to be saved and restored before and after executing the move and checking for being in check. Alright, that's this last piece, these moving pieces methods, they are pretty small, but apart from the en passant and the castling logic, this what took me the most time, because well, not to program, but to think of how can I do this. The fact that you undo moves, I had to, well, it took me some time to get to that idea. So, as you may have noticed, my methods are generally quite small. I can click, well, that's a square. Square is nice. These are, so as you can see, there are no methods that are pages and pages long. It usually, sometimes it's a bit more difficult, but usually pretty small. And that's the official recommendation. Try to keep it within 6 or 7 lines of code. I am an experienced programmer, I am the experienced programmer, but I'm not an experienced Smalltalk programmer. But I was pleasantly surprised to see that it is not very hard to keep those methods small. Just do a lot of refactoring, and as you can see, I still have work to do, because this one here, yeah, it's a loop. Within the loop we have an if and even another if in that one, so this should be refactored into something smaller. But okay, I will do that. Now, okay, you can check all this code, just download it from GitHub and see for yourself, for example, how I did the castling stuff. So now it is time to demo. I will first put 2 human players against each other, Anatoly versus Victor, a classic game. And I do this because I have now full control over which moves I am going to make. So I want to demonstrate the en passant, so I am going to put d2 to d4. Black has a very strange move of h7, h6. d4, d5. So the white pawn is now in the proper position, and oh yeah, as you can see, for debugging purposes, it's black's turn, and black has 18 possible moves. So either the C pawn or the E pawn will go 2 down. I'll make the C pawn go down into danger zone, and the white D pawn has on D5 has 2 possibilities. He can go straight ahead to D6, or he can do an en passant on C6. C6 is empty. The en passant pawn is on C5, but you can capture it to C6. I won't do that because there are more conditions. I will just play a brilliant A2, A3, and yeah, black also has a very good day, H6, H5. So now let's look what is permitted for white. Again, we are looking at the D5, and lo and behold, D5 is only permitted to go to D6, and the en passant is no longer permitted. Alright, let's demonstrate that it actually works, because now we are going to move the other black pawn down by 2 into the danger zone. D5 can go ahead or can do an en passant capture on E6, and we are going to do that. E6, and yes, it captured. Here you can see that we captured, and the black pawn that was here is gone. Alright, next up, castling. It's black's turn, so black, well, A7, A6, doesn't matter. Let's try queen side castling. First we move the bishop out of, the knight out of the way, and A6, A5. Now we move the bishop away, C1 to F4. Okay, black turn, so G7, G6. Now there's only one in the way. We got a rook here, the queen there, but E1, its only permitted move is going to D2. Yeah, this hole here. So we move the queen out of the way, D1 to, well, D5. And black will do F7, F6. As you can see, because we moved the queen out, we have 53 permitted moves. So this is what makes programming chess difficult, because it's just horrendous how many things, and for all these 53 moves you have to see if any of the moves will result in check. So these are all safe, you can all play them. And we are interested in E1, the king. So E1, what can I do? D1, D2, those are obvious choices, but you can also go to C1. That would be the castling move. Let's do that. E1, C1. Yep. Queen castling move. Alright, brilliant. And you have to believe me, that's shoot the king have been in check, or should any of these squares be in check, then castling would not have been permitted. So that was the winner's Anatoly. That was en passant and castling. And now we are going man against machine, or I should say woman against machine. And Beth is going to demonstrate some castling, check. So we are going to use our knight for that, b8 to c6. And ooh, look at that. So I'm playing against the bot. The bot is called Bobby Fischer because he's playing random moves. And what he did, he started with white. So first he moved one of the knights out, and then the other. Okay, that's very nice. So anyway, Beth is going with the c6 knight to d4. Okay, pawn move, and d4 to f2. Sorry, I should pay attention. d4 to, did I type right? f2. What am I doing wrong here? d4. Sorry, my mistake. Not looking right. I know. One of the first things I have to do is create a decent board where you can move with a mouse, then you wouldn't be able to make these mistakes. But it worked. So we put our knight on f3, and then the king was in check, and the king could make two possible moves, either with this pawn or with that pawn, but he chose the g pawn. So g2 captures s3, and white is no longer in check. Very good. And Bobby Fischer won because Beth was really depressed after this brilliant move by white. Now the last one, and then we're coming to the end of the video, is bot against bot. Both will be called Bobby Fischer because there's no variation in the name. And I put a maximum number of moves on it. The maximum number is 100. As you can see, the bot has again played against itself. So yeah, because he's doing only random moves, there's no real motivation to put the opposite player in check. If it happens, it's pure coincidence. There is no, well, it's pure chaos. I mean, the black king is over here, right? The white king is all the way over here. So we have some pawns blocking each other. The queens are all gone. Nice. And you can see what's happening here. So the first check is only in the 38th move. Here's another one. And you see, yeah, checks. I don't see any promotions or castling moves, but we can say do it, and ups, another 100 moves have been played. Oh, I see a very good move. So the black b pawn was promoted to queen and instantly put white in check. So something had to move here. Yeah, the king was probably on b3. Oh, and it's, yeah, the king was on b3 and took out c3. And look, 3 times check, but Byte managed to save itself every time. So, alright. So I hope to make more automated players that are a little bit more clever, and then I can let them play against each other. So as you can see, this program needs several improvements. The first one being a much better board that you can operate by mouse. This is how I currently start the game, as you can see, but of course you want to have a nice menu where you can choose which kind of players, how many moves maximally, and those kinds of things. This is algebraic notation, but what we really want is short algebraic notation, so this should just be F3. And well, you should be able to read the piece from the move, but that is not so easy, because at the point several pieces could be attacking the same square, so just C6 might be ambiguous, and then you have to check out if is it ambiguous or not. And yeah, you have to see what pieces could have played C6, if it's necessary to put a piece name here, and even then several pieces could go to C6, so you might also have to, well, it's not so easy. It sounds easy, like okay, we want to have short algebraic notation, but it's not so easy. I will do it. And we need way more clever computer players. So, this was the first time in more than 25 years that I did some Smalltalk programming. I must say I really liked the reacquaintance. In the future, I will begin work on version 2.0, and when it is finished, I will share the results on this channel. I hope you have enjoyed this video. If you have any comments or questions, please post them below. In the description of the video, you will also find some links that I hope you will find useful. Bye!